today we're going to talk about translating math using variables, but first and foremost, let's actually define what a variable is. A variable is a symbol, usually a letter, that represents something unknown, and it can be any letter in the alphabet. You'll see X, you'll see A, B. I mean, really and truthfully, any letter in the alphabet is used for something that is unknown. This would be an example of a variable. So we have three different variables that are here. Another thing that I want to define is an algebraic expression. An algebraic expression is a mathematical phrase that usually includes numbers and variables, aka a letter, and operation symbols. So we're going to look at some algebraic expressions first, but notice how I have stated that it uses operation symbols. Now, what am I meaning by operations? I'm meaning this right here: addition, subtraction, multiplication, and division. Those are the four basic operations that we use in math. So let's build a table and let's establish some code words that maybe would mean either one of these operations. Take the word sum, for example. The word sum is the answer to an addition problem. So that's the first code word that I think when that would imply addition is to be used. For subtraction, I thought of the word difference. Difference is the answer to a subtraction problem. So let's go ahead and complete the answer to a multiplication, and what's the answer or the code word that is the answer for a division problem. So to finish that, we've got product and we have a quotient. So sum, difference, product, and quotient, all the terminology used as the answers to an addition, subtraction, multiplication, or division problem. And you were just thinking, why in the world did you have to learn that back in elementary school? Well, it has definitely shown up here. So I want you to pause the video and I want you to think about what are some code words that would be used to imply to use addition. Code words that would tell you to use subtraction. Same thing for multiplication and division. And then once you get some words down, then press play and we'll see how you did. Alright, so these are some words, some code names or code words that I have come up with. So in the addition column, I've got sum, increased by, add, added to, plus, and more than. In the subtraction column, I've got difference, decreased by, minus, subtracted from, subtract, and less than. In multiplication, I've got product, multiply, times, multiplied by. And in division, I've got quotient, divide, and divided by. If you have any code words that are not listed in this table, definitely bring them to class. Let's talk about it and see which category they definitely should fall into. Now, you'll notice that I have two. I've got more than, the little asterisk beside it, and I have the code word less than. And this is what it means. Write it backwards. And we're going to talk about that a little bit more with this first red example that I have down here. So let's go here. With this example, it says 6 less than W. Now, less than is code word for subtraction here. So we know that we're going to use a subtraction sign. Now, you cannot go in order like this, 6 minus W. That's not what this is saying. It is saying that 6 is less than whatever this number is for W, or whatever this variable represents. 6 is less than that. That's not what this says. This says that W is less than 6. That's why you cannot put them in order as they come in the sentence. You have got to write them backwards. So what we should do is we should put the 6 here and the W in the front. This represents what is stated here. 6 is definitely less than W. This would be an example of taking a statement written in English and making it into an algebraic expression. let's move along and let's write an algebraic expression for this statement here. It says 2 times a number increased by 5. Now we've got a couple of code words in here. First I see times, which is talking about multiplication, and I also see increased by, which is referring to the addition. So there's our code words, and those are the operations that we're going to use. Now for 2 times a number, you could do a couple of things here. You could do 2 times, use a little dot, a number. Now I'm going to make the letter X represent a certain number. You could have put the letter N, any variable representing this is unknown right here, so any letter of the alphabet will do. 2 times a number, and that right there, all of this is increased by, increase means add, by 5. You could do that. Now definitely use in parentheses because the 2 times a number is what is increased by 5, not just this number. It's 2 times that number. So without the parentheses, 2 times x plus 5, if you had the dot here, it's going to look like maybe 2 times a number plus 5, when really it is 2 times a number. That quantity right there is increased by 5. So I can erase that multiplication dot there and just put the number and the letter beside each other to represent multiplication, and it would be right. If you're wanting to use an operation, make sure you use parentheses or just a grouping symbol to illustrate what goes together. Let's go and let's do one more. This blue example at the bottom of the screen, I'll scroll it up. And you're going to have to look at your table in your notes. So the example is the quotient of a number and 31. A quotient, that's a code word. And if you'll look back up into your table, quotient represents division. So we can do a couple of things here. Division, to me, you can use your little division sign, or you can use a fraction bar. We've talked about a lot of fractions so far, so either one of these would work. With division, it kind of goes in order. So a number, I'm going to say n this time to represent a number. We don't know what it is, it's unknown, but a number and 31. A number and 31, the quotient of a number and 31. So a number divided by 31. Now if you're going to write it in a fraction, put whatever comes first in the statement on top and what comes last on the bottom. The quotient of a number and 31. So either one of these would work. Now let's go reverse the translation. Let's take an algebraic expression and let's write what it represents. So there's a couple of ways that you can write an answer to this. The first one, when I'm looking at this, I would say, to explain this expression, 3 minus v. So 3 minus v. I've also written a couple more statements that you could have written. V is less than 3. That would be right. Notice how the V is in the front of this sentence and V is in the back of the expression. Same thing with the 3. Or you could say 3 decreased by V. So there's more than one way to translate this algebraic expression. Now, what if you had an algebraic expression and you had another symbol that joins that? That symbol I'm referring to is an equal sign. So what does that make the algebraic expression? It turns it into an equation. So take this equation, a mathematical sentence that uses an equal sign. Equations are normally used when solving certain things. So the first example I want to give you is a situation. Write an equation, so we're going to have an equal sign somewhere, to show how to find the total profit from selling tickets to the football game if the tickets cost $7. when looking at a situation like this, I try to come over here and think about how would I solve this logically. What would I do? What if I try to put myself in the situation? What if I had 4 people go into the game and it costs $7? How much am I actually going to pay the person at the gate? If I had 4 people going with me and it cost $7, how much would I end up paying? Well, I know that I would pay them $28. Now, mathematically, how could we write that down? How did I figure this scenario out? Well, I did 4 times 7. So I know that I'm looking at multiplication that is going to be used somewhere in this equation. And I know that I'm going to use the amount that $7 is the cost of each ticket. What other information do I have? I have that tickets. I need a variable that would represent tickets. I'm going to say T. I also notice in here I'm finding the total profit. So the amount of money that the gatekeeper takes in, I'm going to say that that is P. So the profit is my total. And I know $7 is how much a ticket is, depending on how many people come or how many tickets I am purchasing. So 7 times the amount of tickets that I need. That is how I'm going to calculate how much profit that the gate person is going to get from me. This would be the equation that represents this situation. P equals 7 times T. What if I've given you not a situation, but what if I've given you some information and I'm wanting to know what is the equation that would represent this table of information? How are we going to figure this out? When first looking at a table of information, I try to start making a connection between the left side of the table to the right side. You know, there's one side length, okay, so that gives me a perimeter of 7. How could I get that? Well, you know, I could add 6 to it. I could multiply 1 times 7 to get that. So I'm going to try to take some of this information and see if it connects with the next stage. So let's take this one, adding 6. So 1 plus 6 would give me 7, so that would check off. Let's go here. 2 plus 6 would not give me 13, so that's got to go. All right, I talked about earlier that if I multiplied it by 7, this would work. So 1 times 7 is 7. Good. 2 times 7 is 14. Too much. Too much. So that is not working either at all. How about you pause the video and see if you can make a connection between this side in respect to the perimeter. All right, I show you what I had come up with. I noticed that if I multiplied the side length times 6, and then if I added 1 to it, I would get the perimeter. Watch. 1 times 6 is 6 plus 1 is 7. 2 times 6 is 12 plus 1 is 13. 3 times 6 is 18 plus 1 is 19. 4 times 6 is 24 plus 1 is 25. It checks off all the way. Now I did a little bit more. I gave a specific variable to represent side length. I said it was S. And I gave a specific variable to represent perimeter, which was P. So coming down here to build my equation, 6 times a side length, whatever that side length is, plus 1 will give you the perimeter. You can put the perimeter in the back or you can put it in the front like so. Either way, this equation models this table of information. We're going to practice more in class. Don't worry. I will see you soon.